give it one more minute, but we can start by asking people to let us know where they're zooming in from. So for those of you who have joined, if you want to drop your city or state, or location. Very cool. Okay, I think we can get started. Um, Hello, everyone. So this is the fourth workshop in a series of 5 prep workshops and then a hackathon. So the last 2 workshops were about an introduction to programming in R. Today is going to be introducing a very basic level of version control, specifically using Git and GitHub. We have our last prep workshop before the hackathon on October 10th, and that's going to be about data visualization in R. And then eventually our hackathon is on November 1st and 2nd. So for those of you who are new, Fairforward is a completely hands-on experience. We have 5 prep workshops that lead up to the hackathon. And we'll be looking specifically at open source, scientific, and healthcare data. Throughout our series, you would have already noticed and continue to notice that we are using FAIR principles: findable, accessible, interoperable, and reusable. And we're prioritizing BIPOC students as well as professionals from BIPOC backgrounds during our entire series. All of our learning materials will be included on our website, biodatasage.com/fair, which you can go in and access. We also have our recordings from previous workshops if you have missed them, that you can go back and watch whenever you want. Cool. So today's focus is going to be specifically on version control. We're going to start off by looking at what Git is, why we should use Git, or why it's helpful to use Git. And then we're going to touch a little bit about Git versus GitHub, and then walk you through the underlying workflow underneath Git and GitHub, as well as demonstrate how to actually push a project into the GitHub space, and then introduce GitHub Desktop as a tool that you could use to simplify all of your version control needs. So there's a lot of challenges when you work on any programming project or a project in general. One of the few prominent and repeating ones are when your computer crashes just out of nowhere. Everything closes down the next day when you open it, and you just lose a lot of your files, a lot of your changes. Or when you just close down your RStudio or your project file without saving it. Or say you want to experiment with something and you don't know if it's the final version you want to keep, or you just want to toy around, and if you want to come back to something new, something old, or if you want to collaborate with other people on a group project, say you want someone to review something or work on the same thing at their own separate times. This is really hard to do so when you're working on a local file in your laptop. So version control is a really good solution for this. You can think of it like Google Docs, but for code. Every change that you make to your code is not only tracked, but it is saved, and you will know who is saving it and when they're making these changes. It essentially saves like little snapshots of your code. So you can compare what specifically was changed, even if it's just one word or one letter in your syntax. Version control also lets you very easily share your code with a team that you're working with. So if you're working with multiple people, you could ask someone to review it. You could point someone to a specific section of your script, and version control is very convenient for you to do that. It also lets you collaborate with other folks working on different scripts in the same project or the same script and contribute to different areas. And it lets you see who contributed to what changes in your script in your file. And it also gives you access to any previous version of your document. So say you don't like a new thing you're trying out and you want to go back to not just the previous version, but even 5 or 6 versions ago, you're going to be able to go back to the original document and come back to it whenever you want. So in our last workshop, we looked at tidyverse functions. As sort of a quick recap and plug-in, we looked at the 6 essential dplyr functions. We walked over how to do very basic data manipulation in the CDC YRBS data, which is the youth risk behavior surveillance data. And we walked over the select function, the filter function, arrange, mutate, summarize, and group by. But say we got to step 5 and your script breaks halfway through. What if you want to go back to step 2 and then work your way down? Or what if we made additional analysis to our script and we kept saving our file as final, 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 final real, final updated? I know I used to do this when I first started out, and it was very frustrating to know what is your actual final file and what was working and what wasn't. And it would turn into something like YRBS underscore working, working, really working, final working, updated underscore real dot R. So all of this could be very easily solved with Git. So you will have one file that's going to store all your versions, not just the previous one. And you can go back and look at what exactly you changed and come back to the previous versions or the older versions if something new isn't necessarily working out. A little bit of a difference between Git and GitHub. So Git lives on your computer. This is just a system that lets you track your changes. Everything is still on the laptop that you're working with. All your files are still going to stay on whatever device that you use for the project. It's completely offline. You do not need the internet to use Git, and it's mostly a personal backup when you're specifically working with Git. Now, what GitHub does is it lets you put your files on the internet. It lives on the cloud. It stores something called GitHub repositories, which I will explain very shortly. But it also lets you share your project with other folks. So you can work in multiple group projects at the same time and have a cloud backup. So this way you can move between devices and not have the need to work from just one laptop when you pick something up completely new. So we'll walk over a very basic Git flow. So I mentioned the word repository or repo for short. You can think of this as a project or a set of files. So this can be anything from your R scripts or other programming languages. You could store SQL, Python, whatever you use. And then data sets you use. So CSV files, Excel files, text files, anything you need for the project, as well as any outputs you generated for your analysis. So in the last workshop, if you recall, we wrote a CSV or exported the data set that we manipulated and wrangled. So that CSV would also be part of this repo. And lastly, any other documents related to your project. So if you wanted to store a PDF, an image, anything else that would help you complete the project and do the project, that would all fall under the repo. It doesn't have to be a specific type of file to be in the folder. So once you have your repo, the first stage that you do in a project or in your Git project is making a change to the specific file. So you have a R script, for example, that you want to make changes to. Whenever you add a change and you save the change, this is called diff. That's essentially adding or saving. And the second stage, which is commit, lets you describe the change. So I'm going to shortly walk over an example so it'll help you like conceptualize what I'm talking about. But committing essentially lets you name what changes were made and describe the changes. So the first thing you do is modify your files, and then you sort of confirm the changes that you want to make and solidify the final version that you want to store. And then after committing, you want to push your files and send it to the cloud. So you're saving the files locally so far. Both diff and commit all happens in your local computer, but when you push, you send and store it to the cloud. You're saving the files on GitHub, which is the cloud platform, and now your changes are documented. And this gets stored into something called a repo, which comes back into the set of files. So the next time you pick up a project, you're going to pull down from the repo, and this essentially updates your files and ensures that you have the most updated, newest version of everything that you changed before. So how do we do all of this on RStudio? So very, very quick recap of what RStudio looks like. If you joined us for our R workshops, you would be comfortable or familiar with the space, but as a quick recap, on the top left of the pane is where you write your notes and your code. So this is an R notebook. And then the bottom left is where you have your results. So usually when you run an output or a calculation, it shows up at the bottom left. On the top left, you have your objects, or what you call an environment. Any data variables, data sets, data frames that you pull in would all be in the right side of top right of your RStudio. And then in the bottom right, you have all your written files. So these are essentially files that you will use for the project. And if that sounds familiar to what I described a repo as, that's what it is. So it's a collection of files that you're going to use for this project. So I'm going to zoom in a little bit and look at the Git pane specifically. So you have diff, which is the first stage that I described, and then you have commit, which just names the change. And then you have these two buttons, pull and push. And then you have something called history, which we'll look into shortly. And you have more settings that you can adjust in your GitHub. So the first step, like I said, is adding or saving files. So this is going to be the stage where you add any new lines in your script, delete any lines in your script, modify anything you need for your project. And as a very quick example, say we wanted to export our filtered data set. In the last workshop, we did all the 6 functions, but we did not export the final data set. So if we were to use the write CSV function again and export a CSV, this would be the change that we make to our R notebook, and this is going to show up in your Git pane. You can see that we changed the R notebook file and exported the CSV, so that created a completely new file in your project. And this is going to be the changes that you made. When you click on the R notebook, it is going to zoom in and show you the little snapshot of the specific code that we added or we changed. So we can see that I added a title called exporting your dataset, and then we added a little note about exporting the filtered and manipulated data, and then we added an R chunk to the notebook along with the code that we need. So this is going to be the new changes that we've saved to the file. And you can also see at the bottom that the CSV we generated is also being saved into this project space. The next step is going to be committing this step and describing the change that we just made. So, and the same Git pane on RStudio, you would be able to see this little rectangular space, which you can name your commit. You can also describe it and tell Git essentially what the change was that you made. So in this specific example, we just created another exporting dataset step. So first, you're going to select the files that you changed and you want to confirm in this commit. And then you're going to name the commit export dataset. And what this is essentially going to do is confirm that, yes, this is what I'm going to change, this is what I want, and this is what I'm keeping in my project as the next step. So once you commit, it will give you a confirmation text. You can see that it shows you the number of files that were changed. So there were 2, the R notebook, as well as the CSV. These insertions, this seems like a big number, and that's probably because the CSV file had that many rows. And then it also tells you that it created something, and you can see that it's the CSV that we generated. So again, a recap, the first thing we did was the diff stage. So we added 2 or 3 new lines within the R notebook, and then we created a CSV file. So we changed 2 files and we created a CSV. And this is the commit stage. So we changed it in the diff stage and then we committed it. So now the next step in the flow is to pushing it to the cloud. So far, all the changes we made were on our laptop, and now we want to push it up to the cloud, or up in my head. I don't think it actually has levels, but I keep picturing it of like going up. So we're pushing it up to the cloud, and you save the files on GitHub, which is the platform that you use to put it in the cloud, and confirm that these changes are now going to be documented on the cloud platform. So that little button on RStudio actually lets you do that. And the next time you open up your project, say you're working with someone else. So for example, if me and Alyssa were working on a project together and I made a change and I pushed it, the next time if Alyssa wants to open the project up, the first thing that she would do is pull down the project. And that would be with the help of this button. What that essentially would do is give her the latest update to the file. So she's going to be able to see the export step and pull down the CSV that I exported into her project space. So it's going to be able to let you pick up the project from any point that you last left it off and work with others in a much more seamless way. So push it up to the repo, pulled it down, and then it's going to let you move into the next like diff, modification, whatever you want to add next. The history button on the Git pane also shows you what changes you made to your project. This is a good way to recap any changes that were made by you, but also by someone else. So you can see that the first step I did was just adding files to the project, and the next one was create an export step to it. And when you click on the specific change, it zooms in towards who made the change, as well as when the change was made. So you can see that I made the change on 22nd September. It's actually so specific, also gives you the time. You can also look at what files were changed, added, or deleted. It's going to show up at the very bottom of the history pane here. So just as a recap of the entire flow that I just walked you over, we first start with a repo, which is a project space, a set of files, a collection of things that you're going to use for the project. And then the pull step, if this is going to be a repeated project, if this is the first time, you're not going to need to pull anything. And then you're going to add or save files, make any modifications. The next step is to commit. So you're describing the change, you're naming what the change was about, and then you push it to the cloud. So this saves it in the cloud platform and documents whatever modifications that you just made. So I'm going to pause because the next step we are doing is just a walk over and a walkthrough of how to actually now bring this flow into a project within RStudio and on Posit Cloud. So I'll pause to see if there are any questions and if anyone has any clarifying thoughts. Okay, I don't see any questions so far on the chat. So I will continue with the walkthrough. So now I've given you the sort of overview and workflow of how Git works. I'll be walking you over how to upload your project to GitHub. And the first step is to register for a GitHub account. So just to give you some simple rules for your username, if this is the first time you're creating a GitHub account, is to use your real name and to keep it short, making it unique so that everyone can identify you, and also not using anything that might be temporary, like the current city you're in, or an institution, or an affiliation, because you want to be able to use the same GitHub username in the future. So you're not going to be picking a username specifically for school. I created one so many years ago and I still use it. So pick something that you'll still like 20 years down the road. So once you do that, the next step is to create a GitHub repo. So I'm going to switch my screen. You're able to see my Posit Cloud screen, right?
Yep.
So right. Okay, great.
Although, do you think you could maybe make blow it up a little bit?
Oh,
Yeah, excellent.
big. Okay, cool. Great. So just for those who are joining us for the first time, we used Posit Cloud as a platform to do our projects for the previous two workshops. This is relatively easy to create an account. If you go to posit.cloud, it lets you create a free account on your own. So that is something you're going to need for our hackathon. So I would highly encourage and recommend creating an account and keeping that ready in hand. But for today, you're going to need a GitHub account. So on your own time, you will have access to this recording and these slides. You'll be able to spend some time creating a GitHub account and playing around with how to push a project. So once you're in and you've created an account, you will see this space, likely empty and new. You're going to find this green button that says new at the top left and click on new. This is going to bring you into a new repository page. Over here, you're going to create a new project. So what this does is the step where you create your project space. You'll notice that GitHub gives you like really funny recommendations for a repository name. I'm gonna go with this because I like it and it's funny. But usually when you have a project, you're gonna name it something project specific. So we would, if I was being serious and I didn't want to call it Studious Potato, I would call it Fair Workshop or Version Control Workshop or whatever you want to call it that makes a little more sense. So I'm gonna go with Studious Potato. And they also give you a little space to describe the repo that you're working with. So over here, I could call it Fair Forward Version Control Workshop. And that tells you what the project space is about. You want to keep your repository public, um, and have default settings that you could play around with at a later stage. I would usually recommend adding a README file. A README file essentially lets you describe what the project is about, give you information on how to use it, where to use it, really helps someone else who's looking at your repo for the first time understand what the project is about, helps your research become a lot more reproducible and transferable. So if I went into any of Alyssa's projects, I'm going to be very easily able to tell what the project is about and how I can replicate it on my own. And after you do that, you want to click on Create Repository. So what this does is create a cloud project for your own use and throw in whatever you want in your repo. So now we're going to bring this into Posit Cloud and create a few files so you can get a feel of what it looks like. So the first step you do is click on code, and you see that it creates a web URL for your Git project, and you're going to click on this little copy button. So what this does is it lets you clone or duplicate your repo from GitHub into either Posit Cloud or RStudio if you're working with the local version, and open up your repo on your laptop. So when you come back to Posit Cloud, you'll see that there is a new project option. If you click on that, you will see that there is an immediate button to let you copy a project from your Git repo. So I'm just going to paste the URL here and then click on OK. So this will start deploying the project. While it does that, I'm going to switch over to the slides to talk a little bit about introducing yourself to Git. So now we've set up the repo on GitHub, so created a project on the cloud, but now you need to tell Git who you are because you just brought in a project, but it doesn't know that you are the one making the contributions and the changes, so you need to introduce yourself. There are two ways to do this. One way is using the Git commands. This is going to be done from the terminal. This is a slightly more like traditional and also outdated way to do it. I think back in the day when we all started coding, this is how we all used to do it. But you would change your username and your email that you created your GitHub account with over here so that it knows that you are the person that's making all of these changes. The second way to do it, which is so much more easier, is using a use this R package. So what this does is just run all of these Git commands for you without you having to manually type it out, but it still takes your username from you and your user email. So let's see if we have deployed our project. Great. So our project is now deployed. You can see that our environment looks pretty much the same, except we don't have like a notebook space. I'm going to open that so we can see it. So once again, to recap the sort of structure of RStudio Reposit, on the top left, you have your R notebook space, R script space, so all your code, your notes go in this space. And then your bottom left over here is where your output runs. Any results calculations you make will show up here. And then at the top right is your environment. So any data sets, data frames, anything else that you bring into your environment will store here. And then at the bottom right, you have the files for your project or repo. So your R scripts, your CSVs will all populate here and you can check what is in your project space. So we are going to start with creating an R script and introducing ourselves to Git. So I've opened an R script and I'm going to paste in some code so that we can run the function and the package to introduce ourselves to Git. So the first step we're going to do is to install a package. Since I've never used this package before, we're going to run the function install.packages. So again, quick recap if you are new to R, or you need a quick recollection of what we did in the last workshop, you will need to install a package before you turn on a library because you're bringing in a group of functions. So we're going to use this package, and that is going to start installing it in your console. Wait for that to run. See, there's a lot of functions and a lot of things that are getting installed. So once you have your package, you could go ahead and turn on the library. So you do this by calling the library function and using the name of the package, which is use this. So that calls in and turns on the library. Once we do that, you can introduce yourself and configure Git with your name and your email address. So I have my name typed out here and the email address that I specifically use for my GitHub account. But this function comes from this library, use this. So we're going to use _git_config. And that what this essentially does is it takes your information, runs the same git commands behind your screen, and confirms that it has successfully connected you to your GitHub account within your RStudio space. So once we do that, the next step is to confirm that this is actually you. Because what if I just called myself Alyssa and used Alyssa's email, right? That's not going to be safe or secure for any of us. So it's not that easy to hack into someone's account. So we're going to use something called a personal access token. And there is a function in use this as well that brings you to a page to create a token. So what this token does is confirm that it's actually you logging in and it's not someone else. So there is no way that I would be able to log in as Alyssa and make contributions or changes as Alyssa. So if I run this line, it's going to pop up a new tab. It's essentially a website page on github.com. And it's going to take you into the settings of the app. There is also a way to manually do this, which I can walk you through right after this, but this is going to let you do that directly from your RStudio window. So you can add a note to it, whatever note you want. Say I want to call it Posit Cloud because I'm connecting it to my Posit Cloud. You can change your expiration. So say you don't want it to last forever. I'm going to let it go just past the hackathon. And it should already have selected the repo for you as well as the workflow. So this lets you change your repo and your files and make modifications and confirms that this is actually you and you are the one making the change. So you want to scroll all the way down to the bottom and click on generate token. Oh, note has already been taken because I was experimenting with this. I'm gonna call it workshop. And I am going to click on generate token, and it'll give you this really long code that I should not be showing you for this long. And I'm going to click on copy. I'll delete the token after this class. So even if you do pause and copy, there's absolutely no way that you will be able to contribute as me. But now that you have the token copied and into your clipboard, the next step is to give the token to RStudio. So we are going to use another function that lets us just automatically paste all of this, called get creds underscore set. And what this is going to do is pull in this function and let you enter your token. So if I run this line, it's going to give you space to enter your password or token. I am going to copy paste this and into here. And then it adds your credentials, removes your credentials from the place that you put it in. So RStudio is not saving your token. And then it tells R that it's actually you creating this repo and connecting as you. So now we have successfully introduced ourselves to Git. We've told that this is actually me. We've confirmed we're secure, we're safe. Now we want to save the script. Say this file is the change that we want to make, and this is the diff that we are trying to make to the repo. So the first thing I'm going to do is save this script. We're going to call it intro git.r. And if you go into your Git pane, you'll see that this popped up. So you have your R project, you have your R script, and you have something called .git ignore. So what this file is, I'm going to open it. It shows up in your project space as well. So if you click on it, you'll see that it gives you a bunch of things that start with .r, but the file essentially tells your project to ignore files that were changed with this extension. So this is important and useful because if you ever generate an R data set or a data frame, you don't want to upload actual raw data that can be sensitive into GitHub. So using a git ignore file lets you do this. So these are the changes that we made into our project space, and we want to follow the steps. So the first thing we're going to do is select the files that we changed and we want to keep the change of. If we click into diff, which is the first stage, you're not able to see my screen, I don't think anymore, the pop-up. Hopefully now you do. You can see that this popped up, and these were the three files that we changed. So we had intro git.r, the project space, as well as git ignore. So if I clicked on intro git.r, you can see that these were the lines I just added. So we introduced ourselves to Git, installed a package, called in the library, told who we are with our name and email address, and then created a personal access token, and then set up our credentials using the token. So this so far has been our diff stage, and the next step we want to do is commit and confirm that these are the steps we want to do and we want to keep. So we can call this introduction to Git. And it's going to take all of these changes that we made and confirm that this is what we want to keep. We want to click on commit, and you can see that we made 3 file changes, 36 insertions, which is just changes of lines in code and script, and that we created 3 different things. So we created an R script, an R project, and a git ignore file. So you want to close this, and you can close out of this, come back into your Posit Cloud space, and the next step is going to be push. So we've created the change, we've committed the change. The next step is going to be clicking on this green button. So if we do that, you can see that it pushed it up to your cloud folder or your GitHub folder into this project space called Studios Potato, and that it's now confirmed. So one way to check this would be to go back into your GitHub, and if I refresh my page, you can see that we now have a R script living in our repo. So say I made another change and did not create a file. We're just going to test it out. So say print hello world. and I use the print function, and I'm saying hello world. So if I run this output, you can see that it works, and say we saved it. So the minute I saved the file, it would populate in the Git pane. And to save this up into the cloud, it would be the exact same steps again. So you would click on the file that you changed. If you do not need to check the diff specifically every time, you don't have to click on the diff step. You could directly just commit. So since this time I know that I just added 2 lines, I could click on commit, print, um, add print, describe it as that, and then click on commit. So this is going to confirm the change I made. So we had 1 file changed and 2 line insertions, which seems about right. And then we're going to click on close. And then you'll see that if you don't push it, it's going to give you this little information line that says your branch is ahead of origin main by 1 commit. What this means is that your current space, project space, has 1 more change that you have committed, but you've not pushed to the cloud. So the cloud is behind by a step. So we're going to click on push, and you can see that it changed up the project space. Now, if I go into the history tab, you can see that we had 3 different steps into the project space. So the first thing we did was the initial commit. So that was bringing in the project. We connected GitHub. We just opened up the repo in PositCloud. The next step I did was introducing myself to Git. You can see that 3 files were changed. And then if you scroll down, it lets you look at what exactly you changed, what the diff was about, as well as who changed it and at what time. And then you can see that the last change I did was to add 2 more lines to the same script, and I just added a print function. So this lets you look at the history of the project. So to recap, this sort of steps and workflow that we had was we saved the files, we committed, and we pushed. So that's going to be your repetitive cycle every time you use a repo or use files in the repo. And you want to make sure that your cloud stays updated and saved every day, or at least at the end of each day when you work on a project. We'll move into a little bit about GitHub Desktop. This is essentially the exact same thing we just did, but it is a tool that gives you a super simple interface to replicate whatever we did without any commands or any specific buttons. Although I will say RStudio is generally pretty easy to follow through compared to the manual Git commands that you will have to do otherwise. But say you want to use another editor or you want to use a mix of editors, but make sure that your project still stays updated. GitHub Desktop is a great tool, especially when you're new to Git and you are getting used to the flow of Git. It lets you very easily update your files without having to know how it works. So this is what the interface looks like. Um, You'll see that the names and the terminology are pretty similar. So on the left, it's going to show you all the files that you've changed and let you select the changes that you want to commit. At the bottom, you can give your commit a name as well as a description. So this is going to let you describe the changes that you make, and you can go into more detail of your commit over here. And the nice thing about GitHub Desktop that I really like is that you can also add co-authors and tag other people in your project. So that way you can keep track of who else is involved and then click on commit. So this will confirm that you want to keep these changes, and it's going to push it into the cloud automatically. You don't have another step. And the next time that someone makes changes, it's going to show up here as a little number. And if you click on pull, it's going to refresh and update the files that you have in your project space. So they also have a bunch of tutorials on the GitHub website itself to walk over not just GitHub Desktop, but also how to use Git and other ways you can use Git. Some of the resources that Alyssa and I really like are Happy Git with R, which is a wonderful textbook and walks you through in much more detail. We will be sharing these slides, so you will have access to the link as well as the Git tutorial. But I think I'll hand it over to Alyssa to wrap our session up today.
Excellent. So I just want to mention that when we do the hackathon, each team will have a GitHub repository created for them. This is partially because this whole kind of process is to help us sort of understand how, like, working in an open resource fashion really works, like in practice as part of a team. So I just want to kind of point out a couple things on like the web browser. Maybe I will share my screen if my computer cooperates. Awesome. Hopefully that worked.
I can't see your screen yet.
Can or can't?
Cannot.
Oh,
Stop sharing.
hold on. All right. Let's try that again. Okay, how about now?
Yes.
Fabulous. Okay. So as I mentioned in the hackathon, each team will get a project repository, right? So I've decided to call this really awesome project one. You will have the chance to kind of name your teams whatever you would like together, so you'll get to change this. But I will make sure that every repository has a README already created, so at least you'll have sort of a template to start with. But even like in the web browser, it is pretty easy to sort of like make modifications to your README file. So for instance, I'm in this repository, so here's sorry, maybe I should step back one. Here we go. Here's the repository, and right now there's just like the one file, the README file, which is going to be like on sort of the landing page of your project. This is where you're going to kind of describe your project, talk about how what data you used, what question you were trying to ask, how you got there. So you'll want to edit this to be like, we used this data, we used these methods, here are some results, right? So it's going to kind of like describe what you did in your hackathon project. And we notice here, like when I hit edit, it actually like pulled up the file for me that I can edit in real time. And then it actually does have like right here, commit changes, right? So if I click on commit changes, exactly what Padma was kind of talking about, right? There's gonna be this, hey, we're gonna commit changes to like updating this README file, what do you want to kind of like, you can change this, by the way. You can say like, I think update's fine, but you could say like added stuff. Probably update would have been fine, but just to show you, you can modify it. And then, then you can say added data, methods, and results, right? And then it sort of presets for me that I am committing this as Alyssa, and I'm committing it to the main branch. So I can go ahead and click commit changes. And then it automatically updates this file for me. So if I go back to my really awesome project like landing page, I now see that those changes have happened, and you can actually look at, sort of right here on the top of your project, it sort of says like, hey, 3 commits have happened, right? So you can even like click on them and like look at like what changes I've made. So there is kind of, even if you like are feeling a little intimidated about like the R Git or the desktop Git, if you really want to just hang out in the browser for like most of the things you can do, like you can add files, you can upload files, you can modify them. I will say you'll kind of hit a wall if you want to start to do more complicated things. But if you're sort of like helping with the writing and descriptions on the team, you can kind of just hang out in the browser and edit that README and kind of do some basic stuff like in the on the website itself. Let's see, did I want to say anything else about that? I think that's all I wanted to say, was just to kind of mention that every team will get one of these. You will want to talk about what you did in the README and kind of put all of the things that you worked on here. Like I said, sort of a big point of this project program is to kind of get us more comfortable with like opening, working in open ways, open science, and then kind of collaborative science, and all of that kind of comes together in these the ability for us to like have these public repositories. Um, and there's tons and tons and tons of previous hackathon project repositories for you to kind of look at and how they structure things as well, which we'll demo like in the hackathon itself. But I think that's like all I wanted to share, was just to kind of say like you can also hang out in the browser and get some of these things done too. We are certainly not like requiring that you work specifically in R, or that you specifically work in command line or anything like that. But each team will need this to work in this repository. And like I said, if you want to use the browser part, that'll get you at least a good chunk of the way there. That's all.
Cool. Thank you. Um, but yeah, that brought us to the end of what we want to talk about for version control. So we'll pause and we'll take any questions that folks have about version control, about Git, about anything else. But um in the meantime, I think we wanted to do a poll, so I'm going to set that up on Zoom. We do have our DataViz workshop on October 10th, which is in 2 weeks. But we wanted to check if folks would rather have a 2-hour workshop or just a 1-hour workshop. Um,
All right, I'm gonna stop the recording unless there's anything else you wanted to put on here.
we could stop the recording. Thanks.